So now jumping right into our session, CO2 systems, what retailers need to know. The goal today is to hear about retailer experiences with CO2 and highlight some considerations for first-time adopters of CO2 systems. And we'll be hearing today from Doug Milu, the Refrigeration and Energy Program Manager with Publix Supermarkets, and Chris Braun, the Senior Project Manager for Construction, Refrigeration, Facility Maintenance with Coborn Inc. So I'm going to go ahead and just jump right into our questions because we've got a lot to get through today. So I will start with you, Doug. If you could just share a little bit more about your company and any relevant refrigeration or climate goals for the folks on the line.
Sure. Thank you for having me, by the way. So Publix Supermarkets is one of the largest, if not the largest, employee-owned company in the U.S. We have now 1,308 supermarkets in 7 southeastern states. One note is we're a founding partner of EPA's Green Chill program. And by the way, this is the 15-year anniversary for that. We have currently 103 stores that have been silver certified, 38 stores with gold certification, as well as 2 platinum certified stores. I only say that because that's kind of a moving target, depending upon when those stores were certified and the time for recertification of those sites. At Publix, we have a very strong focus on reducing our refrigerant GWP in our existing stores to align with the AIM Act that was brought into law a little over a year ago. We've developed a glide path, if you will, looking at all of our sites and the refrigerant that make up those sites. And through our remodel process, for those of you that might not know, our stores get remodeled every 5 years. So within that 5-year anniversary of the store being brought online, we take a look at what the store needs. We do a complete evaluation. Refrigerant is part of that evaluation, and we will go ahead and retrofit to an ultra low GWP refrigerant during that remodel cycle. CO2 being kind of the next generation of refrigeration architecture moving forward with this industry. We believe that CO2 has a place here at Publix, and I'll talk a little bit more about how many sites we have that are using 744 as a primary refrigerant. Morgan?
Great. Did you want to share this quote, Doug?
Yeah, so as one of the largest employee-owned companies with locations in 7 southeastern states, and by the way, if you're taking note, that's Florida, Georgia, Alabama, South Carolina, North Carolina, Tennessee, and Virginia, and we've just broke ground in Kentucky, so we'll soon to be in our 8th state. But we have a mission here at Publix to be the premier quality supermarket retailer in the world. And part of that mission statement has us being responsible citizens in our communities. And part of our job here on the refrigeration program and with our design folks is looking at the impact of the grocery store that we have in the areas that we operate in. And in alignment, like I said, with the AIM Act, and then looking further down the road, 15, 20 years down the road, how do we want to position ourselves and the design of our buildings to become a more carbon neutral footprint, if you will. Now, I know there's a lot of math and things that go into that, but really looking at a sustainable future for Publix is very high on our radar. And looking at these CO2 systems, moving forward, again, they have a place in our portfolio of new stores. We're also looking at how we can incorporate them in remodels as we move forward.
Great, thanks, Doug. Chris, what about you? Can you just share a little bit about Coborn's and your refrigeration goals? Oh, I think you're muted.
Coborn Inc. is a family-owned company started in 1921 in central Minnesota. A percentage of the company is also an ESOP. We operate 66 grocery stores plus convenience and liquor and pharmacies. We cover 5 states in the Midwest, mainly in Minnesota, North Dakota, in Wisconsin with a couple locations in South Dakota, and recently moved into the Upper Peninsula of Michigan with 3 stores that we acquired up there. And we do have a variety of store sizes varying from on the small end to 25,000 square feet upwards to 105,000 square feet being our largest grocery store. Next. Our goals for refrigeration when we were contemplating between using the synthetic refrigerant and natural refrigerant is that we wanted to be future proof. We wanted to make sure when we were spending the capital to do a new store or a remodeled store, that we were setting ourselves up for the next 20 years plus, that we weren't going to put something in and have it be regulated out in the next, 5 to 10 years. We also wanted to make sure that we had good service and install support, just to make sure that we have contractors in the area that could support the technology and that we could get it installed for a cost-effective manner. And it needed to be financially viable upfront cost, and that we could justify it with the total cost of ownership of the equipment over that lifespan of the equipment. Morgan?
Yeah, that makes a lot of sense. Thanks, Chris. So you both alluded to this a little, but I'd love to dive in a little bit more on your experience specifically with CO2 systems so far and looking ahead. So Doug, I'll look to you first.
Okay. Yeah. So, with our new store growth, we're currently on track to finish probably 50 to 51 new stores this year. We have a myriad of prototypes based on the size of the parcel that we can put one of our facilities. We currently have 6 prototypes designed with CO2 as a primary refrigerant. There will be more to follow. I had mentioned this in one other session that we did, where it takes us about 2 to 2.5 years to change a prototype from a traditional HFC refrigeration architecture to a new CO2 refrigeration platform. So that's why it takes a little while for us to kind of switch gears, if you will, on the type of systems that we will deploy in any given location. We have right about 100 stores operating with CO2 as a primary refrigerant. What I would mention is that we started this journey back in 2010. We started with low temp cascade CO2 systems operating with as a direct expansion refrigerant with an HFC topside unit, if you will, managing the evaporator condensers. Those were really key in our decision to move forward because we learned about handling CO2, working through contractor issues, training, startup, and subsequent operational learnings working with the CO2 systems. The majority of our systems are what we've referred to as liquid overfeed. So we have low temp CO2 DX refrigerant systems, as well as we're pumping 20-degree liquid CO2 throughout the entire medium temp cases that are on the sales floor. We now have 6 transcritical CO2 systems in operation. And I mentioned the 7 states that we operate in. We have a pretty good feel for stores that are here in Central and South Florida on how they operate, as well as in some of the northern climates where you have, cooler mean average temperatures within the operating area. So CO2 is really becoming more of a standard for new stores, even though we still have a few prototypes designated as low GWP HFC based. I'm sure at some point we'll be looking at transitioning those as well. What I would mention, I kind of touched on this with, working through the contractor issue. We found that really a key to work with your contractor early on in these projects. So much so we've developed an in-house training center, which I'll talk about in the next few slides. So Morgan.
Great, thanks so much, Doug. That's fantastic. And Chris, if you could share a little bit more about your experience so far too. Oh, I think you're on mute.
Our first experience with CO2 started back in 2020 with our first ground up store with the transcritical CO2 system in it. We've now since done another one, so we have 2 ground up new store builds, and then we did 1 open store remodel with a transcritical CO2 system, which involved partial startup and load switching and different items like that, which was definitely a challenge all of in its own. But luckily we had our contractor on board that helped us greatly through that and managed to get us through all of that. We do use the 80 attic gas coolers on all sites. And our plans going forward are going to be all new builds will be transcritical CO2. And we do have plans as well to remodel a couple existing stores in 23 and 24 and take out HFC refrigerants and put in transcritical CO2 systems and other open store remodels. And that's due to the fact that, as you'll see in later slides that I have, of the utility savings that we're seeing with CO2 versus standard HFCs.
That's great. So the 1 store remodel that you've done so far didn't scare you away from doing a few more?
Not at this point yet. No, we want to keep doing more. So
that's great. Good. Well, we'll talk more about that. Taking a step back about, you've both touched on this, some of the advantages that you've seen with CO2, but really what were the key drivers that you would highlight as to why you chose CO2 over other system types, or what advantages really stood out to you? And Doug, I'll pose this to you first.
Yeah, sure. So, dare I say we were early adopters, but I think we were early enough adopters to gain that operational experience working with CO2. So really, when we sit down and we strategize on what our systems of the future are going to look like, because again, when we build a grocery store, we don't build it for a 3 to 5 year lifespan. We build it for 25, 30 years to be in place and to manage that site and all the systems within it. So when we strategized and looking at where we wanted to be as Publix as a company, 15, 20, 30 years from now, we just thought, well, really, let's just look at what the end game is and let's back into that, figuring out how to make that work. So again, we started this back in 2010, and I can't tell you that it's all been fun. It's been challenging at sometimes, and we'll talk about that a little bit more a little bit later on lessons learned. But really, it supports the sustainability goals that we have to greatly reduce our weighted average of our GWP in our stores. Obviously, first cost of these systems, they seem to be normalizing. When I say seem to be, there's more of them out there. So the prices are coming down for the systems initially. Installation costs, that's coming down. When we first started bidding these stores, the contractors weren't really sure of the unknown, basically, and they seem to be coming in higher than a traditional HFC installation, whereas there's less materials, the copper is smaller, the systems are smaller, so we weren't really sure what was happening there, but working with our contractors, helping explain, and then getting a few off the ground up and running, and then being able to share that experience with other contractors that haven't done that work has paid big dividends now in the installation and material costs. Energy cost is still on the table, trying to figure out how to achieve energy parity. And I've got some reference slides that I showed earlier in another session where we've sub-metered a store's systems for our transcritical, and we've compared them to an equal size store in an equal environment, and trying to figure out how to optimize those systems to gain energy parity with an HFC system. But it's not just about energy cost. I would need to mention that because our program is refrigeration and energy, we're also looking at not only electricity, but water and gas as well in our facilities. So again, I think Chris mentioned future-proof, dare I say future-ready, because really we're wanting to position ourselves, for the next 30 years of these buildings being operable, right? So we want to be ready. We want to have the best operational system that meets all of our check boxes. And when I talk about all of our check boxes, I talk about, the reliability, the serviceability, the redundancy, total cost of ownership, being scalable as we go through remodels. How do we, add on to these systems and change them out effectively like we do with HFC systems today? Redundancy being a key thing for us. And we'll talk about that a little bit more as we go on. But then you have reduced burden from compliance and reporting. So, that was kind of high on our radar, looking at, well, if we deploy these systems and they're operating correctly and we can figure out the nuances working with CO2, then the burden of, EPA reporting gets diminished. And as well as it does, I would encourage you not to just focus on that, but really look at, the whole total package of moving to a natural refrigeration architecture and the gains that, basically we see our grandkids and our great grandkids will experience in having a more sustainable system that's more environmentally friendly as we move forward. Morgan.
That's great, Doug. Thank you so much. And I definitely want to make sure we have some time to dive into some of the training that you guys have done. It's great to hear that the installation costs are starting to come down. So looking forward to digging into that a little bit more. Chris, what about you? Some of the advantages that stood out to you?
So some of the advantages that we've seen on the construction cost reduction. So we've used the CO2 to glycol heat exchangers, and we use the glycol to heat the vestibule in-floor heat for snow melt in lieu of a natural gas boiler in winter months. So we're able to eliminate the cost of that boiler altogether. We use the same heat exchanger for glycol to an air coil to aid with dehumidification in the summer. As Doug alluded to, it's smaller loop piping. The system architecture is considerably smaller than a standard HFC system, so we've been able to reduce the size of our mechanical rooms or keep them the same size and add additional aspects to that mechanical room that don't take up space in other parts of the store. And then with only having one rooftop gas cooler, we don't have to spend money on structural steel for, 2 or 3, 10, 12, 14 fan condensers like we have in the past with HFC systems. So that architecture and raw material costs and stuff have been going down just due to the sheer smaller size of a CO2 system versus multiple HFC systems.
That's really interesting.
Yeah, and then we are seeing one of the other advantages we're seeing is we were always told that you should see anywhere from a 5 to 10% energy savings with CO2 versus HFC. And a lot of that is due to heat reclaim savings. Some of it's due to efficiency in the refrigerant and stuff like that. We're actually seeing better than that. we've got the 2 new ground up stores that we have are comparable to our prior ground up store in, layout, BTU loads and stuff like that. And we're seeing an average of 15% savings, utility savings per square foot, based on our 448, 449 store to CO2. In our remodeled store, which we went from, I believe it was 6 systems scattered throughout the store. Some of them were built in 1982. Several updates here and there, some cases, but we switched it to a new transcritical CO2 system with all new cases. We're seeing 25% energy utility savings in that store, and I'm actually probably being a bit conservative on that just because we've only got 9 months worth of data on that store. We're seeing we are seeing an increase in water usage due to the adiabatic gas coolers up there. It equivalates to about $200 a month. And we're seeing natural gas usage down about 2 to 3% across those 3 stores per square foot.
Wow, that's really impressive, and a great way to transition, because I want to dive into some energy numbers more. That's often one of the key questions here when we're talking about CO2 systems. So we're going to dive in a little bit more about your overall experience with energy performance in your CO2 system. So Doug, I'll start with you. I know you've got some data on this to share.
Yeah, so this chart, it's a bit of an eye chart, and I apologize. However, this was a study that we did at our Longwood store. This was our first CO2 transcritical installation. And we compared this to a traditional HFC store with similar systems, similar MBTU for the low temp and medium temp systems. And what we did, we worked with our systems manufacturer and our controls manufacturer. We sub-metered just about everything that we could within the machine house. And really this is regarding coefficient of performance for the compressors. There's a bit of an advantage there. If you've seen some of the CO2 compressors, you realize that they're much smaller in physical size because of the efficiencies of CO2. So it's kind of no surprise that we got some really good compressor performance. But at this particular store, we learned when we looked at total heating degree days versus cooling degree days, Central Florida really doesn't have many heating degree days. They're mostly cooling degree days. So with higher mean average temperatures, we're seeing at this particular store, which is about 11 miles north of Disney World, if that gives the audience kind of perspective where we're at, it's usually hot. And if it's not hot, it's wet. And then you get a combination of both. So it's kind of like a swamp, if you will. But with that, we're probably averaging about 4% higher energy from a traditional HFC store of similar size and location. So Morgan, if you go to the next slide, you'll see we've created kind of a heat map with our manufacturer supplier, Hill Phoenix. You can see the orange and the yellow from Central Florida down, where we're going to pay a little bit of an energy penalty for these systems, because there really is not, we don't get the relief of having fall or winter type temperatures in these areas very often. We had a fall break here this past week. It lasted 4 days and it was in the 60s, and we were thumbs up. But that's about it for another month or two. But you can see on this heat map, as you go north, as Chris has alluded to, you can start gaining some really significant energy savings based on these systems. And again, I want to stress optimizing the systems after startup, commissioning, making sure that the systems are running correctly, that your drives are dialed in. So really with the right technology, you can not only reach energy parity, but you can save some energy as well based on where the store is located.
Doug, are you seeing any improvements in energy performance? And I don't know if you have the data on this or not, but as you've seen more training on the install base. You're talking about commissioning and getting everything startup all properly done. Do you see any changes as a result of your training efforts for technicians?
Yeah, so I can answer that this way. So when we first started this particular store, which is almost 2 years old now, again, the contractors were not quite sure how to even commission the system. So again, working with our equipment supplier and our controls supplier, we had many visits with the contractor to kind of work through the system. We've all been there and done that when it comes to commissioning HFC systems. We know how to optimize, set superheats, manage case temperatures, manage defrost durations, things of that nature. Looking at run times on compressors, looking at all that stuff, and we have figured out, we've basically mastered how to dial those systems in to reach optimum performance of those systems. CO2, there was a bit of a learning curve. So there's a bell curve of learning when it came to the CO2 systems, not only from handling CO2 and charging systems, but then understanding what the system is supposed to look like. So that's where we leaned heavily on Hill Phoenix and the folks at Danfoss for this particular store to help us understand not only operational sequence of the systems, but how to best optimize those systems. So our contractors, I think, to answer your question, Morgan, learned along with us how to commission these systems to reach optimum balance between operational and then, actually managing product integrity in the store.
Thanks, Doug. That's great. Chris, I know you've got some great data to share as well, so I'm going to turn things over to you to talk a little bit about your energy performance experiences.
Yeah, so I just put together a couple charts here showing kilowatt hours per square foot, because that's probably the best way that we have for comparison. So this one here is just the 3 stores based for the year 2021. You'll see the green line in the bottom right is our newest store, which we didn't open until November, so we don't have a lot of data on that. But you'll see the top line is the R448 store, 45 square feet. The red line with where the arrow is pointing is when we started the remodel. And then the bottom line, the black line, is the original CO2 transcritical store that we did. So you can see how they all are trending lower than the R448 store. And then you can see the sharp drop off in the remodeled CO2 store as we started bringing systems online and shutting off the old systems. On my next slide, if you want to go to the next slide, Morgan, that really shows this is all the same store here. So you can see where the remodel started on the black line in the middle there, and you can see the drop off. And then that's a comparison year over year. The blue line is the year 2020, and then the green line on the bottom is what we've used for energy so far in 2022. So you can see a pretty significant drop off. And granted, not all of that is refrigeration. There was some store lighting that was switched to LED, and some RTU cooling units that were changed out. But you'll see, I mean, it's a pretty significant drop off in average monthly kW usage for that location.
That's great. Thanks so much, Chris. So diving in a little bit more to considerations, takeaways, lessons learned, we've got some questions trickling in here. So would love to talk a little bit more about your experiences and lessons learned or considerations that you would share with anybody that's considering going down the CO2 system route for the first time. So Doug, I'll start with you.
Sure. Yeah, so really early on, it was, the ambiguity with the contractors understanding the systems. But really, once we introduced the systems and worked alongside the contractors to get them installed and started, they realized that it's just another refrigeration system. So there are some components to the systems that are different, specifically working with CO2. You handle it differently than HFC refrigerants when you're doing startup. So once you get over the nuances with handling CO2 as a refrigerant, then the rest of it starts to fall into place, right? So again, going through the installation, going through the startup, and then working with those contractors on support for the long term, it took a bit to get there. So what I would say is, engage if you're about to do a CO2 store in your organization, work not only with your system supplier, work with your controls provider, but also engage early with the contractor that's going to be installing the store, because getting them engaged early on really helps smooth out the construction process. One of the gaps that we still have is with the availability of refrigerant grade CO2. So, we talked in another session about, the bottle shortage with CO2. So for those of you that don't know, the tanks are different. They're like an air gas type of a tank, or like an oxygen acetylene, or the nitrogen bottles that we typically see on site. They're a heavy steel bottle. There's only a few manufacturers. Because there's a gap in the supply chain for CO2 to be readily available in some of our operational areas, we are storing some CO2 in those locations. So by default, I think that we have lent to the bottle shortage that the industry is seeing, because I know that we're not the only retailer that is storing charges of CO2. So we've taken some of the bottles out of circulation. So again, a call out to my industrial gas suppliers and my equipment manufacturers to engage with the industrial gas suppliers to help us close this gap on availability for CO2. Again, during startup, not an issue, because you've got time. You can wait a day or 2 or 3 to get refrigerant on site. But if you do have an issue in an existing store that's operating, you really don't want to wait 3 days before you can get a delivery of CO2. Now, again, that's not everywhere. I'm saying that there's a gap in some areas. One of the other lessons learned was a little bit higher leak rates during startup. And it's not through a system issue. It's as we're doing startup with these systems, there's construction going on. The utility providers on site, they're transferring lines out behind the store if we're in a rural area. They're upgrading transformers. So usually during the startup process, when we're trying to either charge the system or bring everything down to temperature, the utility provider will go ahead and disconnect the power to the building, unbeknownst to us. So what we've learned, what you'll learn with CO2 is it really likes to be in operation. It really doesn't like to sit idle in a vessel. So therefore, there's some relief valves that if the pressure gets too high, the system will safely relieve some of that pressure outside the machine center. So that's what I meant by higher leak rates during startup. It's sometimes challenging. The other thing during leak checking these systems early on, again, we've been doing this since 2010, the leak detection systems, there was only a couple of units that were designed for detecting CO2. So our first round of leak checking were, 3 or 4 people with bottles of soap solutions, spraying down every fitting and valve on the rack, which it was pretty ugly, I'll be honest with you. But since then, there are companies, that develop leak detection with sensors for CO2. So that's pretty much a non-issue at this point. Still working on total cost of ownership. Our CO2 low temp cascade systems and our liquid overfeed systems, those are fairly dialed in. They work really, really well. We've reached energy parity with those units. We're still working on total cost of ownership for transcritical CO2, only because we're only a couple of years in, and I don't have a lot of good comparables based on the maintenance aspect for the annual spend that we will use to manage those sites moving forward into the future. One of the things that I would tell you that we learned early on is, I mentioned this before, is working closely with your systems and your controls manufacturers to review and develop a strategy for reliability and ease of maintenance moving forward. It's no use to anybody, it's no good for anybody to develop a system and making it so complex. You have to have a degree in quantum physics or quantum mathematics in order to understand the control algorithms within the controller. So working with them, ease of use, ease of maintenance, making the system reliable and serviceable from a contractor's perspective is key moving forward. Also with your design, luckily for us, we have an in-house design team here that will develop the first generation of any given prototype moving forward. So we all have input to what that design looks like. And we meet and we discuss our options once we get our retail objectives on how we're going to manage and deploy those systems on the roof for the cases on the sales floor. I mentioned retail. Retail is being introduced to more doored cases on the sales floor, more than ever before. And I can tell you, and Chris might allude to this as well, some of that energy savings we're seeing with new stores and remodels is because of things like LED lighting, EC motor technology, more doors on traditionally open cases moving forward. I had a note in here about walk-in cooler and freezer storage prep areas. One of the things that we learned with the redundancy as part of our checklist that we go through is that we wanted to have diversity within the systems. So our liquid overfeed system kind of pigeonholed us into kind of a one rack system, if you will, for the entire low temp and medium temp systems. Even though those systems operate really well and we've dialed them in, there still is that kind of redundancy issue that if I do have a problem going forward, I put everything at risk at the store. So that's why we have decided to move towards the more transcritical systems, because I'll show you in a minute where we can kind of divide the low temp and medium temp systems within a couple of different racks, which then helps us with the redundancy issue. And then again, looking at the refrigeration design impact on total store operations. When we speak with store managers and the store associates about, do they know what the system is? Have they heard about it? It's like, well, we've heard about it. We don't really understand it. But once you introduce the store associates to it, they realize again that it's just another refrigeration system. It's really more for the learning is more for the contractors and the operators of the systems rather than the retail perspective moving forward. So, Morgan.
It makes a lot of sense, Doug. Do you want to talk a little bit about the staged remodels?
Yeah, sure. So those of you that are operating grocery stores, you know that retail really doesn't like to close a store when we do the remodel. So we try to, at all costs, accommodate retail and not closing the store. So we have a store here just outside of Atlanta that we're planning to do a remodel and switch the traditional systems to a CO2 transcritical distributed system. So this store will have 3 units that will go in the existing machine center. Each unit will be low temp and medium temp, so it'll be basically split suction. So that gives me basically 3 different options within 3 different machines to divide up my sales floor to make sure that if I do have an issue with a frozen food freezer, I've got a meat freezer and an ice cream freezer that I could move product to. So again, when you check the box on redundancy, this system will help us get there. We currently have ink on paper, and we're getting ready to deploy this store. I don't think we'll make it this year, only because as we move forward towards the holidays, we kind of go into this blackout mode where we get out of retail's way basically and let them do what they do best. So more than likely, we'll go ahead and install this store the beginning part of next year. So more to come on this as we create the learnings or work through the learnings of shoehorning in this new system architecture in an existing store. And it sounds like Chris has already done it, and I'd like to collaborate with him if we could.
That's great, Doug. Do you have an idea of the anticipated timeline on this? I know you said starting next year. You mentioned a 2.5-year process
Yeah,
for
so
converting a store
well,
at the beginning of the session.
Sure, great question. So new stores take about 2.5 years from the concept to being able to go to permit with a set of plans. Remodel store, this store, I think we've been working on this almost a year. It's probably been 9 months working through the logistics and not only what the systems are going to look like, but how to phase that through or stage it through the remodel process. Because again, I have to make sure that, you know, the new systems are set in place, the new systems are wired, the new systems are piped, so I can decommission the existing systems and start up the new systems, you know, as we change the cases on the sales floor. So that is a bit of a logistical challenge when you're dealing with, you know, structural integrity of the existing roof. So, you know, we may have to do more bracing of our bar joists in the overhead in order to accommodate multiple units in one location, or we may have to temporary units off to the side along the column lines for better support to facilitate the installation of the new unit. So logistically, it's a bit of a challenge, but Morgan, once we have that worked out on paper, typically our remodels are anywhere from 90 to 120 days. I would imagine that a store with this much being changed would fall into the latter. So we would probably be between 4 and probably 6 months time frame on a store with this much work going on.
Yeah, that makes a ton of sense. It's a puzzle that you have to fit everything together.
That is correct. Unless retail decides that we can close the store, then we'll just close it and do what we do best. But we're going to try and do it with the store open. So this next slide.
Yeah.
I'm sorry.
Sorry, Doug. Since we're talking about that, I was just going to talk about our experience with doing an open store remodel, where it was something similar, but we did only do it with only one system. We were fortunate to have it where it was a large store and we were moving complete departments around, right? So we were able to put in all the new frozen food department with the old stuff still running, right? So we were able to start up the whole frozen food department with the frozen still operating, and then get that system up and running and make sure that system was running as optimally as it could be for a partial startup. And then the one other thing we did as well is we didn't change out any of the walk-in boxes, right? So we took and hung the CO2 coils in the boxes with all of the HFC coils still running in there. So we were able to, when it came time to start up, to get that extra load on there, we were able to shut off the old coils, start up the new ones to bring up that load, right? So you had low temp and medium temp load running in order for the booster system to work. And what actually ended up happening as the remodel progressed and we started taking more and more load onto the CO2 system and taking it off of the old systems, we actually ended up having to turn the CO2 coils off and the HFC coils back on to keep enough load on the HFC system to keep them running until we got all the loads transferred over.
Yeah, so that's a great point, Chris. And when we talked about, you know, putting the pieces of the puzzle together, it is a logistical challenge sometimes when you're doing wholesale change outs of all the systems within a store. And again, we don't like to close the store. So having the scenario where you're doing an expansion and you can set all the new cases, you can pipe them, you can run all your conduit and your comm cables and everything, and then, you know, stage the cycling on and the decommissioning of the existing systems really helps to to kind of put the rest of that puzzle together. So that's a great point. Thank you. So I talked a little bit about, the bell curve of learning for the systems from our contractor's perspective. And quite honestly, we had to learn the systems as well, because we have the 7 states that we operate in. We have about 65 project managers that help facilitate the installs alongside the contractors. So if we didn't know what good looks like or how the systems operate, we would just be left to leaning on the system manufacturers and the contractors to figure it out on their own. So we took the initiative to learn the systems early on and become kind of the SME. So as we go into a new market area with a new contractor, we can be on site and walk them through the installation process, any hiccups that happen there, any nuances that go on with startup and charging of the systems, because there is a bit of a difference typically with an HFC system. Once you pull your last vacuum, you can basically open up the bottle of liquid and let the liquid fly. However, with CO2 systems, you need to be able to vapor charge the system to 150 pounds or better before you introduce liquid into the system. Otherwise, you will have dry ice in your receiver and in your pipes. Now, as crazy and scary as that may sound, don't let it scare you. All you have to do is get 150 pounds back onto the system, and that dry ice will then turn back into a liquid. So it's not the end of the world. So I just want to make sure that everybody understood that. But what we learned in the bell curve of learning for not only our contractors, and now we've employed in-house Publix service technicians working on our racks and our systems. In fact, we're now servicing the store in Longwood that I mentioned earlier, which was our first transcritical system. We had to get people up to speed relatively quick with not only understanding the operational sequence within these systems, but understanding the controls that manage the systems and sequence of operation. So with that, we said, well, we're really taxing whatever training is available out there quite a bit. So we decided about this time last year to move forward with our in-source training center. So we're calling it our Publix Refrigeration University. In this training center, I have a scaled down version of a mechanical center that you would see on one of our roofs. In it, it has an HFC or 449A rack. It has a transcritical CO2 flex mini rack. It has a glycol pump station used for load control of the 2 refrigeration systems. And along with that, I have 7 cases, both low temp, medium temp, as well as 3 evaporators, low temp and medium temp, that are both split up between HFC or 449A and CO2 transcritical. I also have 2 energy management platforms within this training center. So I have the Emerson system, the E3 that's running the HFC rack, and we also have the Danfoss 880 controller operating the transcritical rack. So we give a full spectrum of whatever you would see in our new stores moving forward and some of our existing stores that need to be serviced. You have everything there to train on. The game changer with this facility, Morgan, is I can run failure scenarios on every component that's in the machine center and in the case. Whereas up to date, to this point, all of our training has been in a live store. You really can't shut the meat cases down because you want to simulate a failed solenoid and have a technician troubleshoot the failed solenoid, right? Retail really doesn't care for that. But in this scenario, we can do just that. We can identify all the critical failure points that would happen out in a live store and then simulate that and have the technicians go through and verify that they understand not only operational sequence, the control strategy that operates that sequence, but the electrical components and communication wiring that are managing all of the functions of the system. So that's a huge game changer in this facility. The other thing that we've done is, I did a session with NASRC at FMI back in September about the workforce shortage. So we've engaged with academia, both high schools and vocational schools, to help introduce the students to the world of basically commercial refrigeration. So much so, working with the instructors within the vocational schools, you know, they said, Doug, there really isn't an avenue for me to become familiar that I can even talk about these next generation systems with my students. They're all teaching, and most of us, or many of us that are on this session, have been through HVAC school. We know what that looks like, and you learn residential air conditioning inside and out. And as good as that is, it gives you all the fundamentals of air conditioning, basic electricity, troubleshooting techniques, brazing techniques, and you know, how to enter the workforce and become a technician. The gap that we're seeing is nobody is explaining to the students what this next generation systems are looking like. In working with the instructors, they've all come to me and said, Doug, there is no avenue for me to get trained or even speak, you know, informed to my students about these systems. So last week I met with one of the instructors from Southern Tech at one of our stores here in Lakeland that has one of our new systems in it. And not only was he completely amazed at what he saw, he was so excited to go back and tell the students about what's going on. So we're working on now with academia possibly some internships, if you will, to help bring some of those folks and introduce them to supermarket refrigeration. So more to come. Hopefully we'll have more information on that at our next session. You know, and really it's about, you know, technician retention. You know, we can recruit and we can train, but how do you retain good talent? And what we're learning is that people coming into the workforce today have different objectives about what they want their career path to be. You know, people want to be led, they want to be trained, they want to be treated fairly. And I can tell you, no holds barred, when I grew up as a technician, I was treated like a mushroom. And I won't give you the analogy of that, but it was very little training. If you were going to learn this, you had to seek the information on your own. That has shifted. The industry has shifted. You know, regardless of the equipment manufacturer that you seek to use, they are all engaging with training at specific levels to help you, the end user, and the contractors through this change from traditional systems to new advanced refrigeration technologies. Morgan.
Yeah, this is so huge, Doug. Thanks so much for sharing that. I think you shared a stat at FMI that was something about 6% entering the industry and 16% leaving, which I just thought that stat alone really tells the whole story of what we're up against here.
Yes, ma'am.
Chris, what about you? What stands out as things that you would make sure to share with a retailer exploring CO2 for the first time?
So some of the lessons that we've learned before that we can share them before choosing CO2 transcritical is your climate, right? Up here, it makes sense, right, to do it. I mean, the energy savings is what we're finding is significant enough to make the riskier, higher service, more leaks worth it. You know, and the climate up here, we don't go super critical very often. I think it's like an average of like 12 to 14 days in a year, and that's typically only for a couple hours where we go super critical. We do notice that when the system does go super critical, there does seem to be more issues, right? Oil issues, temperature issues, higher energy, just things like that. We do see a lot more service calls when it goes super critical, right? So cooler climate, you know, an aviatic condenser and different things like that to keep your you know, high ambient conditions to a minimum. the next is the refrigeration contractor. Our contractor on this was the same contractor that did all three installs. Their tech or their installers and startup techs and all that they had worked very hard on being versed in CO2. They made sure they knew everything that was going on, what startup set points, all of these things before we ever got food in the cases in the walk-ins. It's system complexity. It is a lot more complex, right? It's a lot more case controllers. It's a lot more valves. It's a lot more, well, you have to do this to shut down. Different things like that. You know, you have a flash tank versus a receiver. It's the same, but it's different. It's just having to retrain the technician on what CO2 is versus what an HFC is. On an electrical and energy management system contractor is also key. Having somebody that's wiring it that understands how to wire controls. Having an electrician that wires things that understands how to wire cases, how to wire racks, how to wire condensers, all of these things. I think everybody that's on here that's worked out in the field has gone on a service call in the middle of the night because of poor wiring, right? We like to call it chasing gremlins, right? Because you get a communication error on a case controller lineup. It could take you weeks to find an issue with it, and stuff like that. So we were fortunate enough to have, like I said, a quality refrigeration contractor, and then we had a quality electrician and EMS contractor that have done lots of refrigeration case wiring and controls wiring and things like that help benefit us. Next slide. Some of the disadvantages that we are seeing. We are seeing an increased amount of service calls. You got case controllers. We didn't typically do case controllers on our HFC system. So we are seeing more service calls due to case controllers, right? You just have that much more data coming in. You're going to see that much more errors in data, right? So we're still trying to sift through that. Service calls tend to be more intensive, shutting down and fixing repairs on the CO2 system are more intensive, right? Because you have to be more careful about what you shut down, how long you shut it down for, just so you're making sure that you're not blowing off safeties. After power failures, we are seeing, typically if all of a sudden you have a 2-hour power failure, power comes back on, you start that system up in 30 minutes and you're back up and running. We are seeing that you do have to stage these things on. You have to bring case controllers on in blocks. You have to do. So a 2-hour power outage could turn out to be 4 hours before, if you're on a large system, before your last system starts staging on. There also is the lease on, like Doug talked about, on the CO2 cylinders for a full store recharge. We do keep a full store charge on site at all 3 sites. Not only is the CO2 cylinder availability problem, but you're also paying a monthly lease on that, which after a year on 3 stores, that does add up. One thing that we learned is that you do have to tune your compressor VFD harmonics. There seems to be a certain on the compressor manufacturer that we use and the drive we use, there seems to be a certain harmonic in there that does cause excessive vibration. So that's one thing that we did learn is that once you tune those, that does go away. And we are seeing more leaks. Leak rate is considerably more than what we're used to. And part of that is that you do have, if you're servicing and you don't, take the time to do the shutdowns right, you are blowing off CO2. Just due to the pressures, there are more leaks, and things like that. So yeah, we are seeing that. But on the plus side, if you go to the next slide, Morgan, this is an incident that we ran into on one of our systems. Failed 90 like that, and it did blow off, and it blew off considerably. That's the vapor from that thing blowing off in the back room. So that was a pretty large CO2 loss. But, you know, it was $2,500 worth of CO2 being lost versus, you know, $40,000 to $50,000 worth of HFC being lost in that situation. So that is something that we learned. It was due to a mechanical failure in the system that caused vibration, not due to the VFD harmonics like I was talking about before, but due to a valve failure, caused that vibration and caused that crack in that 90.
Thanks, Chris. That's really helpful context. Sorry, were you going to say something else?
I know.
Okay, great. Well, this is fantastic information. I think we could have a 4-hour session on this easily. So there's never enough time, but Chris and Doug, we are so appreciate you sharing the insights. To the folks on the line, I'm sorry if we didn't get to your question. If you'd like to reach out to us, we can try to track down an answer to any outstanding questions, but really appreciate you both, Chris and Doug, taking the time to share your insights and data. And everybody on the line, thank you so much for joining us today. Slides and this recording will be available on the platform in the next 24 hours. And let us know if you have any questions. Thank you so much.
All right. Thank you.
Thank you.